works pretty fine, as you can see. Yep, that's it.
Well, hello again. In this episode, we will add the function to throw stars at our enemies. We have no enemies at the moment, but yeah, we will just be able to, at the end of the episode, be able to click on a place on the screen and it will throw a star to that direction. So yeah, head to your projects folder and open your text editor. First, we need to preload the star from our asset and tileset image, and the way to do that is we are going to use a JSON file. So we will create an atlas for our star, and with the JSON file we will just say like this is the location that you will take. It will cut it from the tileset image. So JSONs are here, so let's create a new file called star.json, and we will load an atlas. We will call it star, and it will take image / tile png as the image, and JSON star.json as the JSON file. So let's go to the JSON file we just created, which is empty. Now we can cheat and copy this file here and paste it. Now we will only have one frame, so we can like delete all this. I deleted a little too much. Wait. Okay. We need another curly bracket here. Or do we? Wait. Okay, just delete this and it should be fine. Yeah. And yeah, frames 0. The image we will be using will be tile.png, and we need to tell it its width, which is 128, whatever. Scale, version, layer opacity, yeah, let them stay like that. And the location, let's quickly check it. Sorry, sure. Tile.png, not this tile. Coil channel, knife thrower, phaser, tutorial, yeah, here, assets, image, and that's our tile file. Oh, which is 64 by 64, not 128. Our star's location is 32 to 0, and its width and height is 16. Sprite source, just give the same values here. Yeah, and this should work. Now we loaded the star here. Okay, we can just get rid of these tabs and open your level.js file. Let's just try adding our star as a sprite to begin with. 0 0 star. Actually, let's not make it 0. Let's make it player.x, player.y, so it will be on the same location with our player, so you will be able to see it. Actually, I won't give this physics for now, so it won't just fall down, and I will scale it a little so we can see it better. And we probably need to give it a depth also. Our player's depth is 2, so let's make it 2.1. Then we can just run our live server. Yeah, you can see the star here. Its scale will probably be like 0.5. By the way, I want to check something here. You see the empty space here. I want to get rid of it. But first let's set the star. We can make it a little bigger. Not really, actually. Yeah, this is better. Actually, maybe even a little bit smaller. Yeah. Now, we will have a spinning animation for this star, and I'm gonna use time event for that. Let's show how we will work the animation first, and then we can work on functions and stuff. So give it a small amount of delay, like 50 milliseconds. We want this to be smooth, kinda. And then we will say a time event will basically trigger this callback function every this amount of milliseconds, and then we can make it looped by saying loop through. We can also give it repeat, which will allow us to repeat it a certain amount of times, like it will repeat it 50 times. For these we will use loop, and you can also give it like paused, which can take true or false, so you can just create this function and then start it later. For now we will just give it loop through, that's all we need. And inside the callback function we will say first let's call this star this dot star for now. This dot star plus equals, this means it will this dot star dot rotation plus equals. Rotation is, you know, the angle of the star, and if we like say it plus equals 0.01, it will add 0.1 to its rotation value every 50 milliseconds. So as you can see, it's spinning. We can make it faster, like let's make it 20 and make this 0.02. Still slow, so let's try this. Let's try 0.1. Yeah, better. We can do it faster actually. Yeah, this is much better. So yeah, this gives us the spinning animation. Now I want to get rid of this space here, but I don't have much of an idea how can I accomplish that. Oh yeah, we can change our camera's position. This dot cameras dot main dot x equals, can I say like this dot map dot y, actually not x, so it will change the camera's y value where the camera starts, which is around here. Now this is the top of our canvas, it starts from that corner, and it will take that y value to where our map actually starts. I hope. Let's see if it works. Probably didn't. Let's take this console at the bottom of the screen. Oh no, how can I take this down? Whatever. It says, oh, but it doesn't give an error, it just, our camera doesn't show our map at all now. Maybe minus this dot map dot height times 16. This dot map dot y times 16. Really? What if I give it 0? It's default value. Yeah, right. If I give it 100, we need minus 100. Okay. Then this dot map dot height, maybe this is a very small. I think this is just 20 because we have 20 tiles. Maybe if we make it times 16, this might work. Yeah, but like now we have space on the bottom. We can actually do something like take the controller out of the screen, like give it its own place. Like, where did I define that? Cross. Oh, it's the gamepad, of course. Start gamepad, and maybe we can gamepad.y equals, like, if we give it 100. It's not visible here, huh? Why though? What happens if we give it some depth? We can't, it appears to be. So this part isn't our canvas. Let me actually change the background color so I can see exactly where our canvas ends. So instead of white, let's make it black. So yeah, now we can see our canvas better. It goes until down here, but oh, probably we also need to change our camera's height. Plus equals, let's say, this dot map dot height times 16. Yeah, this should make this area visible. Yeah, okay, it's great. Now we can take this back to its own place. Gamepad. No, actually we need to plus equals this dot map dot height times 16, I guess. No. It's 2 down below right now. Yeah. Plus 16 minus this dot gamepad dot height, maybe. Yeah, I don't know. Yeah. Wait, sorry. Okay. Now if we jump, it's a little bit visible, but yeah, not that important. Also, should we just set the velocity to 0 when we are jumping and then stop, like in our release function? How did we made it complete the flip animation when we release? But wait a second. Oh, if it's on floor, okay. Now what I want to do is also take this here and let's see what happens now. Wait. It's oh, sorry. We need curly brackets now because it's, you know, 2 lines. Yeah, okay. Can we like... Okay, I think that's better. Okay, I can't even remember where we left off when I was interrupted again. Sorry, let's just go back to our folder here. Sorry, I just got paranoid. Someone's gonna see me recording a tutorial. Whatever. Let's run our live server to see. Yeah, we set up the position of the controller. Now only functionality I will add is to be able to click on somewhere. Okay, so to get the position of the mouse, you know, when we click on a place on the canvas, we can use something like, I'm writing it in this time event function for now, so we can get the output in loop as we click on a place. Console log this dot. We don't actually need to click. This will give us the location position of the mouse. Active pointer, I believe. Am I misspelling it? Maybe. Let's see. Yeah, as you can see, it gives us the position of the mouse. Now let's comment this out for now. We want this to be applied when we click anywhere on the screen, so maybe I would normally create a sprite that will fill the whole screen, but probably I can't. But like, can I do something like this dot scene dot on pointer down? I don't know. Console log. Nope. Okay. Then let's create a sprite. This dot interactive screen, let's call it, equals add sprite. Origin will be 0, 0. Let's give it hidden. Let's give it a depth of like 3. Set scale. Actually, let's make it like, scale will be, okay, let's say set scale like 1 to 2. Then we will work on from there. Let's see how it looks. It's on top there. We need set origin 0. Okay. Are we seeing the actual whole thing right now? Probably not. We set origin 0. Does the order of these functions matter? Like, if I take this here, perhaps? No, we probably need to add here the width of this thing, which we probably can't while creating the sprite. Yeah, we can't. What's the width of this thing, really? Console log this dot interactive screen dot width. I actually want to zoom in a little here. Really? Okay. Can't I actually not inspect? No. Default levels. Is there something here? No. Maybe here. Appearances, workspace, auto. Whatever. I just want to take it down, but I can't seem to do that right now. Whatever. Now, what I wonder about is if I make this 2, will it be 100? No, it's always the same. Okay then. So then we want to add here. Actually, let's just write 50 here, and it should be. Oh. Sorry, half of it, so 25. But it's not exactly right. I don't know. Okay. Then let's just give this like 4. Is it too much? 3? Yeah. Yeah. And then here, let's try 3. Let's try 5. 6.2. 0.1. 15. Okay. 16. 18. Now let's also give this set scroll factor 0 so it won't move as we walk. Oh, this changed the whole position thing. Let's see where it is right now by zooming out. Okay. Take it down. More and more. We we can actually zoom back in now. We can see it on the screen. Okay, let's give this like 100, 50 maybe. Okay, 520, 510. Okay, perfect. Now if we move, as you can see, it stays in the same place. Now we can just set its alpha to 0. Okay, now we can we also need to make it interactive. Now this dot interactive screen dot on, pointer down. For now, let's just take this from here into this function. Oh, we need a comma here, sorry. Do I need a little bit of comma? Yeah, it doesn't work when it's 0. It's basically not active when it has 0 alpha, so make it 0.01 instead, and as you can see, it points out the location of our pointer. Now let's try for now this dot star dot x equals this dot input dot active pointer dot x, and same thing for the y value. Let's see. Weird. Like console log star.x. What is the location of it to begin with? 96. This is 300. I wonder what causes this. Probably something about tile maps. I messed with a lot of this pointer stuff on my previous game, and I can't remember how exactly I figured it out, but it must be something about tile maps. So let's try minus this dot map dot width maybe times 16. Oh, this is too much. Like, okay, let's delete times 16. 265. Really, I'm not sure. Let me check my previous project, how I did this on that one. Input active pointer. Oh, game dot input that active pointer dot world x. Okay, let's try that instead. Instead of this, game dot input dot active pointer. And instead of x, we say world x. Yeah, that's the thing that really matters, I guess. So we can actually use this, and just instead of x we say world x and world y. Yeah, now as you can see it works fine. Now we want it to be teleported there. We want it to be slowly moved there. And I used that before, but I can't remember what it's called. Let me quickly check. Like maps, there must be, yeah. Maybe move, something like that. Yeah, move to. It takes the name of the sprite and the location, and this is like speed or something, I guess. So we will add this dot physics dot move to, and name of the sprite, which is this dot star, and then the location, which is this as an x value, and then the y value too. Wait, this dot star projected pointer world y. Yeah, then let's say like 500. Delete this stuff. Let's try it. What does it say? Velocity of null. This is not a physics sprite, that's why we can't use physics on it. So let's just make it this dot physics dot add instead. Yeah, as you can see, it moves towards the location we click now. Now we need it to be slow down and stop at some point. Like, is this the velocity we give to it? Like, if we slow it down, will it stop at some point? No, it probably won't. We can add a time event here, like a second later. This dot star dot set velocity. Actually, wait, I'm thinking of something. Yeah, let's just try setting it to 0 for now. Like if we throw it down, yeah, it stopped right there. We also need gravity for this star, I think. Let's actually set a gravity value in our main file. Like if I give it 200, it should be fallen by itself. Like, wait a second. Oh, we do it like this. Yeah. Well, good morning. Now, the only thing that's left to do is to make the star stop at some point. So in our time event function, let's add like this dot star dot. Oh wait, sorry. This is doing the same thing. Let's make it do it sooner. Yeah, kinda okay. But let's not make it 0 just instantly. Instead, make another loop function inside. Say loop through
And actually, let's not make this loop true, but repeat this dot star dot velocity x, because we already have a gravity on the y-axis, but we need to slow it down on the x. But I think we need to do this like star dot body dot velocity dot x, I think, and inside we will say this dot star dot body dot velocity dot x minus equals 1. So it will just slowly bring it down, but maybe like this it throw an error, as you can see by the white screen. This also doesn't work. Wait, where? .39. This dot time dot add event. Yeah. Oh, we didn't give it a delay value. And now at 42, repeat. Like I'm sure there's a, oh, it's because of this. Yeah, okay. Now if we throw it, should have slowed down. Yeah, but let's make it faster. Yeah, no, let's change this to 10. Yeah, actually, but okay, let's make this 20, make this 5, and divide this by 5 also. Took even a longer time. Oh, it only affects the speed on x-axis, so like let's zoom out and have a better look at its behavior on the x-axis. This is a little hard to see, but yeah, as you can see, it goes pretty far. I think it's fine, maybe, but yeah, I think it's fine for now. But do we need it to go any further than that? Yeah, this is kind of more accurate, I think. It shouldn't be that heavy in real life, I don't know. Yeah, this looks fine for now. Now, finally, let's add a collider, so it just doesn't fall through platforms, or maybe it can actually, like, not sure. Yeah, let's have it free fall, cause it might just stuck on the land and then enemies can collide with it and die. Yeah, it's better to just free fall over the platform layers. Now, one thing I want to add is to come in the update function. Update function is a function in Phaser that will constantly check for things. Like I want to add if this dot sorry, if this dot player dot y is greater than, I don't know, 100, which means we are like falling. And actually let's make this more logical by saying this dot map dot height. So if we are down below the borders of our map, this dot scene dot start level, so it will restart basically. Turns out we already are below those levels, so it's constantly restarting right now. Do I need times 16? Oh, height, not height, sorry. This dot map dot y. Play, sorry, player. And I really do think it's height. It's constantly restarting. Now let's try. Yeah, as you can see, as soon as we get out of the borders of our map, it restarts. And also, like, the velocity keeps the same when we are walking. Should it be that way? Yeah, probably it's fine. Now, I want to make this block jumpable. I quickly want to turn back on debugging. I want to add something like our hitbox, this collision box, will be smaller when we are flipping, because you know our body kinda shrinks when we tuck. So let's get to our flip function. Here, up left. Let's say this dot player dot body dot set size, this dot player dot height divided by 2. Yeah, now it works, but okay, let's make it like 20 by 20. Wait. Yeah, it looks fine. Let's also add this to upright. Not there. Inside the if statement. Now if we try to jump to that block, we can do that, but after successfully jumping, we should turn this back to its default size, which is actually our character is 32 by 16, right? Yeah, and I really think it shouldn't be. As you can see, it's way above our head there. So let's just say, where did we define the player? Right here. That we can add this set gravity to here instead of giving it its own line. And then this dot player dot body dot set size. The width is 16. That's okay, and the height should be around 20. 24 maybe, and we will also need to set some offsets, because it's still starting from the same place and shrinking from the bottom. So we need to we shrinked it 8 pixels, so we need to get it 8 pixels down, like this. Okay, this is much more accurate. Now let's go back to our what were up, left, up, right, those. Yeah, go back to those functions, and from 24 we will make it like, I don't know, even 12 maybe. And we will give it an offset again. Actually, wait, we don't need its own line. Just put it here instead, and let's copy this here, paste it. We will set the size to 14 and make this 18 perhaps. Yeah, it looks pretty accurate, but a little too small maybe. 16 to 16. Maybe. What about 20? Not 20. Wait. 4. So yeah, 12. Okay. Let's also put this here, and then on the release function, if we are on floor, what if we release on okay, instead of if, I will make a while here on floor, is false if we are still on air. No, wait. We need to just wait until we hit the ground and trigger it afterwards. We can use a time event. Let's call it check if on floor. Let's give it something like 50, make it loop, and we will say if this dot player dot body dot is on floor, but not is on floor. We will check until we hit the floor, and then we will do these. Yeah, and then we will say, actually I think we can say, and after this happens, this dot check if on floor dot paused equals true, so it will pause that function, it won't keep running. Yeah, this looks much better. Now inside that function we will also set our wait, I'm looking for the first one here, the original one. Copy that line and paste it in here. so it will just get our character back to its own box size, as you can see. Oh, wait. Now what happens here? We are on floor, so it I think we also need to create an if here and run this only if our character is not already on the floor. So put a comma, not a comma. This mark just sorry, I can't remember. So it will work when body.on floor is not true, when it's false. So how many lines are there? 10, 11. Yeah. Now on the release function, we need an else statement. So what's up there is what it's doing when our character is on air, and in the else statement we will say it what to do if we are already on the floor, which is just these two functions. Let's get it like this, it's a little more tidy. So now, yeah, everything seems fine. Can we jump to this block? We can't. Look, there's a problem now. Why does this happen? What is this console log again? Yeah, let's get rid of it. We can walk, but after jumping once, after jumping again, it's probably because this time event doesn't stop properly. This time event called check-in floor. Let's test that by a console log function. Still running. It's not running for now. It's still not running. It seems to work fine for some reason. Oh yeah, when we try to walk in midair, it doesn't stop running. Now, what's the reason behind that? Because when we walk in release again, we are not on air. Let's add here this dot check if on floor dot paused equals true. So when we hit the floor, it will pause it no matter what, but it's not defined in here. Okay, so let's get this function out of here, so it will be defined outside, like here, and let's get it here. And is this outside our create function? Of course it is. So yeah, let's get it here. And yeah, let's go back down there and in the if statement just say this dot check if on floor dot pause equals false. Now did this fix the issue? Seems like it did. Yeah, it works fine now. Now, why we can't jump there is because, yeah, it should be slightly more upwards. It's a little down below our heads right now. Yeah. So we need to work on the offset. We change it by 4 here, so actually in our original one it's still a little above our heads. We need to make it even smaller, I think. Let's try this. 14, 16. Oh, when we hit the ground it changes back to... Okay, wait. Let's comment these out for now. Yeah, go back to what we were doing. 24, 28. Really? The 32 is the original size, so the offset. What? Oh, wait. Sorry, this is upright. I need to edit this. Yeah, let's try 24 here. Okay, 16 and an offset of 12. It should be bigger than that, like 22 maybe, and a little bit more to down. No, like, yeah, this is much better. Yeah, okay, so this is the original value, and here it should turn back to the original value. Wait. Yeah, copy this and paste it here. And then go down. Here we will change the value to 16 by 16 maybe, and this will be 4 then. No, yeah, this is a better offset slightly, maybe 10. Yeah, 10 looks pretty good. Yeah, this looks pretty good. Now if we turn off the debugging and test it, also we were just started this episode to throw stars, and our star just free falls kinda. So when we click on the interactive screen, let's make it first this dot star dot x equals this dot player dot x, same for the y value, and let's first make our character play ninja throw, and let's create a time event that waits like I don't know how long this animation takes. Let's quickly check it actually from our preloader file. Wait, preloader ninja throw, its frame rate is 6. There's 1, 2, 3, 4, 5 frames. Really? 0, 11, 12, 13 and 0 again. So let's make it 5, so it will exactly take 1 second, but we will probably throw it on the second frame or something, so let's leave it like that. And all this function down below will be until here, right? Yeah, will be inside the callback here, so it will trigger after 500 milliseconds. If we try it now, yeah, as you can see, but it's not exactly centered to our player. We need to add this dot player dot height -2 to make it go from the center of our player, and here we need to add width. We actually let's keep it for now, cause we will have to change it if we are directing left or right. We actually won't have to do that probably. I don't know, wait, it still doesn't look that accurate. Okay, so now its x value is far right here, so yeah, we should make this minus instead. Minus and divide it to 2. Yeah, now the x value is kinda right, I guess. And the y value should be, oh wait, this should be width, not height. Okay, yeah, this is much better. Yeah. And now I also want to like, let me first thing I want to do is console log this dot what were we saying, input dot active pointer dot world x. So what I want to do is, if it's on this half of the screen, our character will turn left, otherwise it will turn right. So let's just test. It's like from around here, 73, 33, 98. So this is like 100. Okay, so if this dot input dot active pointer dot world x is smaller than 100, then this dot player dot flip x equals true, else it's false. Yeah, so if we throw it like but we don't want to wait to change the direction of our character, so like pointer dot down, yeah, let's put it here, and there is some, yeah, okay, let's tidy it up a little bit. Yeah, see, it works pretty fine, but like if we're throwing to right it's okay, but if we turn this direction it's a little forward to our character because it's minuses a value on both. So what we want to do here, if this dot player dot flip x is true, then we want to add this so it will be more to right in the x-axis, else we want to minus this. Yeah, now it should look better on both sides, yeah, as you can see. Yeah, I think it looks pretty cool, like, oh, but the world X makes it you know, it just we don't need the world X for the turning thing. We need to make this just dot x, but not the wait, the values will change. I think it takes our width as the x and y value, like 450. Is it 450? Yeah, it's 450 in our main file, I think. Let me quickly check. Yes, it's 450. So we probably need to say here 225. Yeah, works pretty fine, as you can see. Yep, that's it for this episode, and see you on the next one. Good. We are going pretty good, I think.